Hello class, I hope you are doing well. Today we want to continue with the Form 2 syllabus, the topic Trigonometry 1. And in the introduction, I want to introduce this concept of trigonometry, and then I want to split it into two aspects, trigono and then metry, whereby we want to specifically deal with a triangle and then the measure. When we are talking of a triangle and the measure, what we are interested in is actually the measure in a triangle, which will involve angles and then the sides. So basically in this topic, we want to see how are the angles and the sides in a triangle related. After introducing that, then we bring in the concept of trigonometric ratios. Trigonometric ratios, and definitely you know a ratio is just a comparison of two particular aspects. Now I will come up with a right angle triangle, and then when we are talking of these trigonometric ratios, we want to specifically embark on a right angle triangle, whereby we look at these ratios. And then a right angle triangle, I want to give this A, B, and then C, and then I want to call this theta, and then according to this B and theta, we will say that B is adjacent, B is adjacent, A will be the height, and then C will be the hypotenuse. You remember this hypotenuse from the previous topic of Pythagoras theorem. Then we will use this right angle triangle and this hypotenuse, adjacent, and height in dealing with these trigonometric ratios. And then the trigonometric ratios, we will have sine, we will have cosine, and then we will have tangent. So basically these are the three concepts of trigonometric ratios that we will deal with. So if we start with the sine, sine theta, and even before I deal with the sine, there is always a shortcut of remembering these trigonometric ratios, which we talk about SOHCAHTOA. Basically, the three parts relates to the three trigonometric ratios. Then this one is sine, this one is opposite, and then this one is hypotenuse. Hypotenuse for the car, we have cosine. We have the cosine. We have adjacent. We have adjacent, and then we have hypotenuse. Then for the TOA we have tangent, we have opposite, and then we have adjacent. So basically we will use this mnemonic to always remember these trigonometric ratios. So basically we are saying that And this one, the theta, we can have this one also as it is the opposite. It is the opposite of this particular angle theta. So, with regard to this triangle that I had drawn here, we are looking at sine theta. Sine theta, the trigonometric ratio will be from our mnemonic, the slope. Sine theta will be the opposite of this angle, and then over the hypotenuse. Then the trigonometric ratio of cosine. So cos theta, we have adjacent. The adjacent of that particular angle over the hypotenuse. Then the trigonometric ratio of the tangent. So we have the TOA. So we say tan theta will be equal to the opposite of that particular angle, then over the adjacent. So basically, these are the three trigonometric ratio that you ought to always remember, and always remember this mnemonic of SOHCAHTOA. You will always find it easy to remember these three trigonometric ratios that we will be dealing with in Form 2. Now, after we have dealt with the three trigonometric ratios, we want to see the relationship between sine, cosine, and tangent. We want to see how do these three relate. Now, the relationship here follows that you take tan theta. We are still making reference to this triangle of ours. You take tan theta. Tan theta will be equal to sine theta over cos theta, and it just doesn't come from anywhere. We can still prove how tan theta will be equal to cos theta. Still making reference to right angle triangle. We have our theta here. Then let's say we have this as the hypotenuse, this as the opposite, this angle, and then the adjacent of that particular angle. Remember, sine theta is equals to opposite over hypotenuse. So basically what we are saying is, if we cross multiply, we'll have, you take hypotenuse, you multiply by sine theta, you will get opposite. Then the cosine theta, still making reference to that right angle triangle, the cosine theta is equals to the adjacent over the hypotenuse, So we again cross multiply, we'll get hypotenuse multiplied by cos theta will be equal to adjacent, the adjacent. Then tan theta, we know from the trigonometric ratio, tan theta is opposite over adjacent. That one we know from the trigonometric ratios that we just wrote. And then now if we make a replacement, you clearly see there is this aspect here, opposite being equal to hypotenuse multiplied by sine theta. Then this particular aspect here, whereby adjacent equals to hypotenuse multiplied by cos theta, then you just make a replacement here that tan theta equals to where we have opposite, we replace with hypotenuse multiplied by sine theta. Then where we have adjacent, this is what we have here. You take hypotenuse multiplied by cos theta, then we can actually cancel out hypotenuse. Then we remain with tan theta being equal to sine theta over cos theta, and that one becomes the relationship between tan theta, cos theta, and sine theta. I hope you have enjoyed our today's lesson. Have a blessed day.